Okay, so today we're going to talk about statistics and trying to fit a scatter plot, scatter plot, into the equation. The difference was we were talking about linear regressions. Today we're just going to do quadratic regressions. So today we're going to be doing our quad reg. Okay, it is a common core. Okay, so it's statistics and interpreting statistics with data. And it's basically, it says, fit a function to the data to solve problems in context of the data. That's the common core target that we need to do. So everything we're doing in here has to fit to the common core because that's the test. I didn't make the test, but that's the test you guys are going to have to take to graduate from high school. So hopefully we're hitting the right stuff. I mean, it's only fair to you. So what are we going to do? So in example 1, what I'd like to do first is let's just graph the points. We've got point A, which is 0, 5. So 0, 1, 2, 3, 4, 5. There's point A. 2, 1. There's B. And 3, 2. 1, 2. There's C. Now there could be some curve that should fit into this. And you know, whether it looks something like this, we're not sure exactly where the graph is, but there's going to be some quadratic that's going to fit in those, okay? So what we want to do is actually come up with the equation that fits all three of those. The way we do it is let the calculator do the work. So we're going to put it into our calculator. We're going to do the same thing we've been doing before. The difference is this button right here. This button right here is the only difference, is the quad reg. So we're going to do the quadratic regulation. So we're going to need to go list 1, right, and list 2. Well, for us, the list 1 are going to be the x values of my point. So I'm just going to go 0, 2, and 3. And list 2 is going to be 5, 1, and 2. Okay? Micaiah, question. Okay, that's okay. Do you want to sharpen it? Yeah, go ahead. So, everybody's got their calculator, right? So let me put it so we can see it on the board. We're going to go ahead and follow the steps. The steps say go to stat. So everybody turn your calculator on. This is really easy. This is super easy. We just have to pay attention to do it, right? It's really easy, okay? So we're going to just go to stat. Okay, first button, stat. I want to go to edit because I want to put some numbers in. So I push edit and enter. Okay, so now I've got some numbers in my calculator already. I want to clear them out, okay? So to clear out my old data, just highlight the list. Remember how we did this? Highlight the list, push clear and down arrow, okay? To highlight the list, if I want to clear it, highlight the list, push clear and down arrow. So you need a clean list. We got to clean it up so we can put new numbers in, okay? So we're going to put in, for the x value, 0, 2, and 3. And for the y values, for list 2, we'll go 5, 1, and 2. Grace, you can turn off a light if you need to, sure. Okay. All right, and I can maybe change the light on this. Maybe. There you go. Does that help? Is that better? Well, then you can't see my calculator.
You can't even see it.
Grace, how's that? Can you see it there?
You're in the very front. You should just move to the front.
All right. So let's go ahead and keep going. So now what we want to do is we've entered the new data. Everything's in, so let's go to stat again. So go push stat again. And now we need to calculate an answer. So this is where it's different. We've done everything the same that we've done before. But the difference is we're going to go to this quad reg because we're going to do a quadratic. That's what these are. These are quadratic models. So I'm going to go ahead and push enter. I need to remember that it's in my list 1 and list 2. I put my numbers in my list 1. So I'm going to go list 1, comma, list 2. Okay. And then I'm going to push enter. I'm going to get my answer. Kaboom. So here's my answer. In fact, it gives me the form y equals ax squared plus bx plus c, right? We've seen that. So here's a, 1, b is -4, and c is 5. So our answer, we're just going to put those numbers in our equation. So we're going to rewrite this as a y equals a 1x squared minus a 4x plus 5. Okay, that is the actual parabola that is going to graph these points. Okay, probably goes something like this. Looks something like that, right? That's the equation of that line. Okay, now let's put it into context of a real problem. Okay, so if we've got a film, okay, think about this. Yeah, Julia?
How did you enter L1
Yeah, I'll go back to that. Okay, real quick. Clear.
Hit enter, it gives you-
Yeah. So if I go, Julia, go to stat, right? I'm going to go to calculate. So you're with me here, right? L1 is by the number 1. See it in blue? See right down there? It's in blue, so I go second, L1. You got it? The comma's right above the 7. Comma's right above the 7. And then L2 is in blue by the 2. How am I doing? Did you get it? And there it is, enter. All right, let's go back. Now, the next example. So first of all, in context of the problem, a 16 millimeter film strip has different running times with different diameters of the film wheel, okay? So if I think about this, just in a problem, if the wheel's really little, it's going to spin pretty fast. That makes sense? Think about it. If you got a film and the wheel's really small and film's flying off of it, right? It's going to spin pretty fast, right? But if the wheel's really, really big and you're taking off the same amount, okay, it's going to spin pretty slowly. I mean, think about something as big as the Earth, right? I mean, if it's that big, you'd hardly see it or feel it spin, wouldn't you? Yeah. So the larger it is, the slower it's going to spin, as long as the tape is being pulled off at the same rate. If it's super small, what's going to happen? Pull at the same rate, it's going to spin pretty quickly, okay? So what we have is the diameter of these film wheels. So, you know, with 5 inches, 7 inches, 9.2 inches. So as the reel gets bigger, the time to unload it gets larger. That makes sense. So first of all, let's make a scatter plot. So here's my diameter. Here's my time in terms of minutes. I go by ones on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and of course there's a 14, okay? On the time, which are the y values, I have to go all the way up to 44, right? So I'm probably going to go by 5s on this side, so I'll probably go 10, 20, 30, 40. Okay, how am I doing? Am I doing all right?
Yeah.
Everybody with me? Alondra's good. Anybody else? Okay. So let's graph it. Let's do a scatter plot. So I'm going to have to guesstimate where the points are, right? So if I go to 5 and 5.5, I'll guesstimate 5.5 about there, right? I just need a picture of it. 7 at about 11.2 is about there. 9.25 and 16 is right about there. I've got 12.25, I'll estimate that, and 33, which is up here. And then I've got a 13.75 and a 44, which is up here. So what I see is it really does kind of curve. It isn't exactly straight at all. And if I were to lightly sketch it in, it could be a real big parabola. It could be, okay? If I sketch it in lightly, it could be a parabola like that, right? And of course the back half of this parabola we wouldn't use because that's, you know, negative time. Impossible, right? But it could be a parabola. So if we want to find the quadratic model, which is what we're going to look for, we want the quadratic model to model this, let's put our data in. Let's let this be list 1. Let's let this be list 2, okay? So I'm just going to use my calculator. Okay, we'll go through this again with you so you can see it. Let's go back to stat. Okay, we're going to do edit. I'm going to clear my old data. So to clear my list, I highlight my list name, L1, I highlight L1, push clear and down arrow. Okay, let's clear list 2, highlight list 2, push clear and down arrow. Now, just put the new data in. 5, 7, 9.25, 10.5, 12.25, 13.75, okay? And list 2, 5.55, 11.12, 16.67, 22.22, 33.33, and 44.45. Okay, got them all in there, okay? So once I put them all in my data, do not push clear. Don't push clear at all. You want to push quit. Don't push clear, quit, because quit will quit the program and we can come back into it. If you push clear, you might clear one of your last numbers, right? Don't push clear, push quit. So quit's in blue, second quit, okay? Now, we want to calculate our answer, right? So we got to go back to stat. We got to go to calculate because we want to calculate an answer. So we go back to calculate, stat. This time we go to calculate. The one we're trying to calculate is our quadratic regression. So I'm going to go down to my quad reg. How am I doing?
Good.
I'm not. Everybody with me so far?
No.
Okay, who said no? Okay, all right. Enter. List 1, right? We got to tell list 1. List 1, comma. List 2, okay? List 1, list 2. Don't forget the comma. List 1, comma, list 2. So you're telling it what list to look for, and then I push enter and I'll get my answer, okay? Now, here we go. 0.397. I could probably round that at 0.4. It's pretty close to 0.4. You guys agree? Yeah. If I want to be super accurate, I could go 0.397, but it's close enough to 0.4. I'll probably use negative 3.12 for accuracy, and I'll use probably an 11.94 for accuracy, okay? And if you're off by a little bit, that's okay for me. If you choose to round differently, as long as you're close, I'll give it to you. So I'm going to go ahead and write that down. So my quadratic model would be y equals my negative 0.4. Nope, it's not negative. My bad. Positive 0.4 x squared minus 3.12x plus 11.94. Okay, that's my quadratic model. Model means equation, okay? That's my model. Now, it gets pretty easy because if I want to predict the time for a 15-inch reel, I'm just going to plug it in, right? So I'm going to do is plug it in, right? So I'm going to go, all right, y equals 0.4 times 15 squared minus 3.12 times 15 plus 11.94, and I just let my calculator do the work. You guys agree? Don't make it too hard. Let my calculator do the work for me. Slide this down so you can see it. All right, got the brightness up probably a little too much. Turn the light off maybe, the lamp. There you go. Is that better? Okay, so I'm just going to go 0.4 parentheses 15 squared minus 3.12 15 plus 11.94, and I get an answer of 55.14, and that's in terms of time, and that would be minutes. Pretty easy? Okay, so our homework, and you're going to need graph paper, page 377, 8, 11, 18, 29, 36, and 58 to 60 is old stuff, is review stuff. Okay, so I'll stop recording, and we want to get working on this.